Good afternoon, everybody. We'll give a couple of minutes for everybody to get in. Okay, this afternoon we're going to begin working with with two of the main packages that you will need to do a data science project. And I'm going to try to make sure that everybody can follow. You've got options. You can either watch the workshop and watch what I'm doing, or you can uh, also do it yourself and follow along that way. The advantage of trying to do it yourself is you can try things out and change things and see what the impact is. But either way, the student shared directory has all of the files that you will need in it. So what I'm going to do is I'm going to begin by making sure that everybody can knows how to get a file from the student binder. So let me share my screen so you can see what I'm doing. And for the first part, I'll share the entire screen so you can see everything that is on my screen currently. And so what I'm in is I'm in the student binder. And so if you uh, go to the student binder if you haven't already done so and see the one that says Stephen Addison Resources, you can see that there are three PowerPoints and four other folders in there, which are Jupyter notebooks for this or Colab notebooks. For this afternoon, the one that you need is the one called ASRI 2 Python packages. And basically, what you should do is download it from the student binder just by going, selecting it, moving to the right, going to the down arrow where it says download, and just clicking download. It'll scan it and it will download it. And so it is now downloaded to my computer. And if I look at it, it's there. It has a little one after it because I already had it downloaded. But anyway, so then what you would want to do is you would want to go to your Google Drive. And so I'm going to go to my Google Drive. Well, in fact, I'll start it from scratch. So here's the Google page. So I'll find the link to Drive. Here's Google Drive. It's not the one I want. I've got more than one. So I'll find the one I want, which is this one. I've got uh, here a thing that says Colab Notebooks. And so what you want is you want to get that folder into the folder that's called Colab Notebooks. All you've got to do is it is basically drag it there and it will upload. And once it's in this folder, you would be able to use it. So it is uploaded somewhere. Let's see. Yeah, here it is. Here's the one I just uploaded. So all I'd need to do is double click on it and it would start in Colab. I'm actually not going to use that one because I'm going to operate from somewhere else. But if you get to that point, so I'm going to stop this share. And what I'm going to do now is I'm going to go to a share that allows me to have chat up and which would allow me also to be able to see you while I'm sharing. So it's okay. So I'm now just sharing my browser, and I've got the file that we need already loaded. So if you double click on it in Google Colab Notebooks, it'll come up, and you should be able to see this file. And the let me make some things visible for me. I do this so I can monitor chat, which I can't do if I'm at full screen. Okay, so Python packages, what are they and how to use them? We actually met some this morning, but there's lots of them and they all do different things. We'll introduce some basic ideas today, and then what we'll do tomorrow is we'll begin to take a deep look into how to analyze data. Today's is just an introduction to show you how to load them, how to load files, and things like that. I'm not going to use Google Slides or PowerPoint. I'm going to use Google Colab as the teaching tool, and everything is actually like that I would put in the slide is in the text sections of this Colab notebook. So everything should be available to you. The We'll start. There's two things we have to learn how to do. We have to learn how to do some basic plotting, and we have, because one of the things you'll want is graphical output, and we also will have to learn how to get those data files that you have into Google Colab. So that's our two tasks for today. Is to One is to look at some basic plotting, and the other one is to do some basic manipulation of a data file. I'll show you one way to get a data file into Colab this afternoon. I'll show you two or three other ways tomorrow, but the way I'm going to show you this afternoon is the simplest way. So the uh, one of the things you'll see is parts of this notebook are adapted from Plot with Pandas, Python data visualization for beginners. That's material that's on towards the end. And the reason that I chose to adapt one was if you need more detailed explanations, you can go to this web page and you can get them. The web page isn't interactive, though, like the Colab notebook is. The so the This site is a good resource about pandas usage. Today, what we'll do is we'll do direct downloads of data rather than putting them on our Google Drives. This is a good way to get data into Google Colab, but I'll show you how to actually put it on your Google Drive tomorrow. The other thing is I'm going to show you some ways of generating data today because we will need data. The actual method of generating data is not the purpose of our studies. I need to generate data just so that I can draw some plots. So I'll introduce methods, but I'm not going to really teach you how to do it. I'll talk a little bit about it, but it isn't necessary for you to learn how to generate the data in the way I'm going to do it today, particularly for getting plots. It's just that I need some data to use, and since I want to make sure that you all have it, I've written code in the notebook so you can generate data without having to download files. But anyway, uh, one of the things I'm going to do is I'm going to use the Python range function, and the Python range function is can just be written as range and with a number in parentheses. And so so for instance, if you put range 5, it will generate the numbers 0, 1, 2,
You're
3.
done with your lunch? Yeah, what did you have for lunch? Huh? What did you have for lunch?
Somebody is talking on a
And
live
shit.
microphone about lunch. If you could please turn your microphone off. Anyway, so basically, range is a function that generates numbers. Notice that it always starts from 0. So when you generate range, you always end up with the last number being one less than the number in your range. And that's a feature of Python. Many languages start everything from 1. Python starts everything from 0. So the first entry in a list is the 0 entry, where you might expect it to be the 1 entry. And that's just something to get used to, and people get used to it quickly. In fact, most old languages started from 1. Most modern languages start from 0 when they enumerate things. So it takes a little getting used to, but anyway. So what I'm going to do is the first thing that the notebook does is it introduces a package called PyPlot, which is a small piece of a big package called matplotlib. If you ever heard of the computer program MATLAB, this matplotlib basically duplicates all of the graphical capabilities of MATLAB, and the piece called PyPlot, which is a small fraction of it, probably includes everything that you would ever really want to use. So you can see in the code block that I have that I'm going to move to the top of the screen. It says we begin by importing the PyPlot module, and here's how you do it. Import matplotlib.pyplot, that selects the piece as PLT. So that introduces the plotting module that I need. Then the next thing is I have written a piece of code that says assign the range of values of 100 to a variable x. So x is something here that doesn't contain a single value. It's going to contain 100 values. And then what I'm going to do in the next line is for each value in that range, I'm going to square it. That's what the **2 means to get my y values. So that will give me 100 y values, which are just the squares of the x values. And then I'm going to, and the next command is the command to actually create a plot. And finally, the last command there is how you show the plot on the screen. So what essentially I'm going to be doing then is I'm going to generate a simple plot that plots a 100 numbers ranging from 0 up to 99 against the square of those numbers. And so I'll run that code block. And it will run for a few seconds. And then what it does is it very quickly generates an output plot for you. So one of the things is when you've got data, look how fast you can get a plot using Python. So all of those pieces of code, there's 5 lines in the piece of code. 2 of them are used to generate the data. And the first, the fourth, and the fifth are all you need to actually do the plotting. You need to import the library, you need to create the plot, and then you need to display the plot. And that's all it takes. Now, it's not a complete plot yet because the axes aren't labeled. But we do have a scale on that because that happens automatically. So you can see the x-axis runs from 0 to 100, and the y-axis ranges from 0 to 10,000, which is what you would expect because we are squaring 99. So anyway, that's one way of getting a plot. So I also want to show you how you can get some curves. Now you're going to have data, and you're just gonna have to plot it. So the pieces about how to generate the data are just there for me to generate data because I didn't want to cover importing data and plotting all at the same time. I wanted to be two separate events. But one of the things I can do is in the next block, I've also imported math as MT. And the reason I imported math as MT is I needed to be able to use pi, and math gives me the value of pi. You can see I've written mt.pi in the code. And so this time, what I've done is I have created a variable named t and given it 100 values using the range function. And then I've calculated both an x value and a y value from it. And basically the x value converts it into angular measure, and the y value calculates cosines. And then I have the same two lines: plot x against y and show the plot. And again, the three lines that generate the data are just to generate data. You don't have to know how to do that, but that would show you how to do it. But that then generates for me a curve like that. And you can see that what I've got is I've got a function on the y-axis, which is the cosine function. Ranges in value from -1 to +1, and you can see that well, it's in radian measure. That's the x-axis. But again, I just wanted to be able to generate a plot quickly, and that's one that we can generate. I could use NumPy to do the same thing, and there's also a function called line space that you can use to generate evenly spaced points. And I've told you the code for that. And essentially, that's another way of generating these without using the range function. And so here I've used NP to plot a sine, but the plotting parts are just the first line and the last two lines. The other two lines are about generating the data. So here we go. This one plots the
Excuse
sine.
me, sir.
Go ahead.
So for the import math as MT, does it also require that you also import matplotlib?
So I already have imported it. So one of the things is once you import it in a block, okay, I imported matplotlib here. It's imported. It's now available to me in the rest of the worksheet.
Oh, okay.
So once you import it somewhere, it's available at all points below it. Now, if you want to be really sure it's there, you could put that line import matplotlib. Okay, that same line. However, if you don't, it would actually still work. If you do, it doesn't change anything. It doesn't actually re-import it because it's already imported, but you can see that. So actually, let me grab that line. I'm going to copy this line here. Whoops. It did something I wasn't wanting it to do. Okay, I fixed it so it's back to where it was. Now what I'm going to do is I'm going to go to this piece of code, and I'm going to create a blank line, and I'm going to put. Why did it do that? Well, I was trying to do it. I just went ahead and typed it. So it's there now, and we'll clear the output. And so I'll go ahead and run it, and you'll see it does exactly the same thing. It didn't take any time, so it didn't actually reload it because it knew it was already loaded. But having it there doesn't hurt anything, is the point. Okay, and I actually was going to address that in the next code block. So in this one, I'm going to show you how to do two plots on the same graph, because sometimes you're going to want to do that. And the both PyPlot and NumPy are already loaded. But I have the code in there to load them again anyway, because as I've said, it doesn't change anything. So you can see I generated the X values in the same way, and this time, as I did with NumPy, and this time I've got two Y values, which I call YA, which is the sine function, and YB, the cosine function. And I plotted X against YA. I then plotted X against YB, and then I'm going to then we'll actually show the plot with both lines drawn on it. So let's see that one. And so you can see that we've got this time the sine in blue. We have the cosine in orange, and it shows those colors automatically. And the so so that's basically how you can do it. Now, some of you, because I can see some of you on my screen. Some of you I know are following along, some were watching. So what I'm actually going to do at this point is give a couple of minutes so that you can try these things and see that they work for yourself. And if you have questions while that's going on, I'd be happy to talk to people also. But I'll give you a couple of minutes to try things out for what we've done so far. And included in trying things out, I mean, you could change things. So, for instance, if I go into this one and edit it, it's, I could. So I've edited mine to have tan. So Mohammed asked a question for general use, is using the math. They're actually modules, not directories. But is it better to use math or NumPy? It's better to use NumPy. And are we supposed to know what each of the procedures in the modules do? No. I'll be teaching you how to use a variety of them, but basically I'll be telling you which ones are useful, and I'll be showing you how to use them. So while you were trying some of these, I changed the cosine to tan, and we'll see what happens there. And you can see that it plotted the tan function, but since tan isn't bounded like sine is, it kind of squashed the sine plot onto the one axis. But you can plot all of the trig functions. And almost anything else that you want. So one of the things I suggest that you do with these is when you play them offline, change things in them and see what happens. So, for instance, in this one we've got the range of 100. Well, let's change it to 500 and see what that does. And the answer is that it really didn't do very much, because all it did was basically put more the dots on the same plot. So you can try things a lot and see what happens. So one of the things is you've got plots, and you might want to be able to keep those plots, because when you exit Colab, you lose all of this, right? So what if you have a plot and you want to keep it? Well, what I've done in the next block is I've added some lines to the previous one, and it says that the text between the next three lines are specific to downloading an image from Google Colab. What that means is that this doesn't actually work in Jupyter Notebooks. Most of the things that I do don't have to be changed, but the download instructions are different. And what I'm going to do is I'm going to take this. I'm going to save the plot in the following way, and I'm going to download it. And so I'll run this, and what you will see is, or if you run that, it will just download to your computer. The other way that you can sometimes download things is you can just drag them to your desktop. So one of the things I could do is I could click my mouse on here and just drag the picture onto my desktop, and then I'd also have it. The advantage, though, of the download is it produces the file in a format that you want. So I chose a JPG. If you just drag it to your desktop, you get a PNG instead, which you may be happy with, but anyway, it's up to you. Okay, that's some basic plotting. And the next thing, or one of the things that you're going to be dealing with really frequently in data science is plotting bar charts and pie charts. So now what I'm going to do, Leiji has a question. Go ahead.
So I was just wondering, the naming convention that you have given before the downloading, that needn't be already done in the codes. That is, you can just name it anything as you transfer it or
Yes.
as you download it. Okay.
Yes. Yeah,
Okay.
I just picked the names which are reflective of what the figure is. So you can call the figure that you save. I call it sine cosine.jpg. You can call it anything else you want. That will work.
Okay, thank you.
Okay. So uh, now what I'm going to do is I'm going to look at some bar charts. And again, we still have matplotlib downloaded, but just to be sure, I'm going to download it again. Now, one other thing I should tell you is you'll go away, you'll have a Colab notebook, and everything will have worked, and you can load it again and it will show you all of the outputs, but none of the data will be there. If you actually need to regenerate things, you have to start from the top or at least execute all the commands needed to get where you go. So that's one of the reasons it's useful to have the imports at various stages, because then when you come back to it, you can just start from that frame rather than having to find where you actually loaded it. Because the loads don't persist across sessions. They're good in the session you're working in, but they don't last until the next session. Okay, so a bar chart. Well, what I'm going to do this time is I'm going to the uh, uh, put in some data that will produce a bar chart. I first imported math PyPlot, and then I created some data, and I just picked the numbers 5, 25, 50, and 40. And then to plot a bar chart, I basically specify a bar chart. I specify it's coming from PLT. And what I want to do is I want to plot the range of the length of the data string against the data. And that's what the line 3 does. And then after doing that, I want to show the plot. So I can run that piece of code. And you can see that what we get is as a bar chart. The length of the data is 4. So you can see that basically Python centered them on 0, 1, 2, and 3. Which remember that when you use that range function, which I did, it is going to always start from 0 for you. Got a couple of questions. Brianna, go ahead.
I was gonna say, Maggie, you can go first. She had her hand raised for
Oh,
me.
okay, I thought hers was still up from before. So, Lazy, go ahead.
Okay, thank you. So I was just wondering, what does that dot stand for? 5 dot? Because I remember you telling that, if we add the dot, it is like the floats. But
And
here
that's
it's not
exactly,
the.
yeah, that's what it is. I purposely use floating point numbers.
All right. Okay. So it just still means the float, is it?
It still
Here?
means yeah. If you see a dot after a number, it's always the decimal point. And people who write in Python, if it's 25.0, are always going to write 25 point because, uh, well, uh, people are lazy. so so.
So in this, but you did not mention how many decimal points that you need after, but it is just choosing to have one decimal point. Is that correct?
No, the when I make them floating point numbers, the numbers will be as big or can be as big as a 64-bit number can be. So we can have lots and lots of decimal places. So once it's a float, it's depending what else you do with it, it will make the result as big as it needs to.
Okay. Thank you.
So Brianna, go ahead.
Yes. So I know you probably will mention this like later in these lessons, but so is there like kind of like a form where you add like error bars into this, or again, is this just in later?
Yes, I mean all of those things. So what I'm going to do is I'm going to build things sequentially. Uh, so uh, so I could actually just do everything at once, but if I did that, you wouldn't learn how to do any of them. But essentially, anything you might want to do is possible within these packages, and you just have to have them. I mean, to produce error bars, we would need to know what the data represented. We'd need to calculate the statistics and all of that, and we're not going to introduce the statistics until tomorrow. so, uh, so, but we'll learn how to do all of those things. But
Thank you.
so Gideon, go ahead.
All right, thank you, Prof. I'm just curious to know why we have the x-axis starting from a minus 0.5. And I'm not sure if that was represented in the code that we ran.
Well, it's a feature of the package. So basically, the since the things were centered on 0, 1, 2, and 3 because of the way the data was created, then it makes something that is really 0.8 units wide. And so in order to do that, if the first one is centered on 0, it extends from minus 0.4 to plus 0.4, but the package always will use fives or whole numbers. It doesn't start from twos, threes, fours, and things like that. But that's just a feature of the package. The data that we actually use in our data science experiments won't be data like that we've created by a range function. So we won't actually see that problem. I could make it go away, the uh, but uh, but since we're not going to do that, then or need to be able to do that. I'm not going to. So Nazanin, go ahead.
Yes, so I'm assuming this is like the basic skeleton or like the code of a like a bar chart.
Mhm.
Like this is the bare minimum that you would need. But of course, like the title and stuff. Okay.
Mhm. Yeah, and we're going to learn how to do all of the other things. But it's so from a pedagogical point of view, on a bar chart, I could have put in everything at once, but it would have been much harder then for you to see what was going on.
Okay, thank you.
Okay, so and in fact, I actually had mentioned the piece about the 0.8 units. The And one of the things that you can do is, let's say we don't like the gaps between these charts. Well, the default is that a bar has a thickness of 0.8 units, but you can specify that for it to have some other value. So in the next piece of code, it's exactly the same thing. I'm plotting exactly the same data, but this time I'm going to plot the things so that the bars have width 1. And there we come up with a bar chart that is not so nice looking. The gaps in the first one were probably too much. Not having gaps gives you a figure that looks a little bit distorted. And so you can play around with this. And so So in the next piece of code, I set the width of each bar to be 0.98 units. And if I do that, it gives me a nice gap between each of the bars. And so the figure is easier to interpret, but it doesn't have all of the space that the first one has. And so in fact, let me change it to 0.99, and we'll run that. And you can see the same thing. I preferred the 0.98 a little better, but that's something you actually play with after you have a figure, and you just want to prettify it. You do want to make figures look nice. You might, and so building on this, you might want your bars to be horizontal rather than vertical. And you only need to make a slight change to do that. You change the bar to bar H. And if you do that, the graph just comes out printed printed so that the bars run horizontally. Do you need to use that one ever? Well, probably some of you might at some time. That's just how you do it. You're more likely to need to be able to use the stacked charts. And so what I've done here is, before I just had data. Now what I'm going to do, and I could call, data was just a label, right? So in this one, I'm going to call the data. I'm going to call one string A. I'm going to call one string B. And you can see that I've got then two pieces of data. I've said that X has range 4, which I just want to specify that because when you've got multiple pieces of data, I had used a range function on the length of the data before, but this time I'm specifically setting it equal to 4, and it amounts to the same thing. And what I'm going to do is I'm going to plot X against the A string and the B string, and I'm just going to specify which one goes on the bottom. I specified that that the A string is on the bottom, and I also specified the colors blue and red for the stacks. So with this, then what I will get is a stack, and and you can see that I specified A to be blue, and I also specified it to be on the bottom, and you can see that the blue thing is on the bottom. So basically, to stack them, all you've got to do is you've got to plot two quantities against the X variable and specify which one you want on the bottom. So that's how you can do that. You might need to be able to draw pie charts. And again, it's easy. I've made up some data. This time I'm going to use integer numbers. So I just didn't use a decimal point. And this time I'm going to want a pie plot. So it's plot.py, and I just called the data. And you can see I've got plot show to show the plot. So I can run it, and I can get a nice pie plot of that data. Now, I didn't specify which one was which color in this, because most of the time you can just let it choose colors itself. But that's how you can get a pie plot. So if you like, I'll give you a couple of minutes to try those out and try some variations. You could put an extra data point in and change the length of the string and see what it does. Somebody asked why is the red at 10 instead of 5? Because basically because what we've got is 5 blue units stacked with 5 red units stacked on top of them. So the red, if you're looking at the one labeled at 0, both of the first ones are 5 units high, and so when you stack them, they add up to 10. And if I suppose I could change this to bottom equals B. For some reason it's not wanting me to. And you can see that in this one, I chose the numbers so they worked out nicely if A was on the bottom. So I kind of messed things up. The problem is there that I should have the stacks in where they're labeled. But if I wanted to, I could put the bottom statement with the other one, which would make it look okay. But anyway, that's how you do it, and just play with those things. Some things will work, some things won't. You could pick other colors. Let's see. Not every letter will work. But probably G stands either for green or gray, and let's see if it actually exists. Well, G, G is apparently green, so we could put a K in, and then we get black. So when you have colors with repeated names, so since B was already taken up by blue, the black becomes K because you use the first letter instead of the last letter. Sorry, the last letter instead of the first letter. But anyway, one of the things here is they're separate, so you can try things out on them. So the next thing is I'm going to plot a histogram, and what I'm going to do is I'm going to draw a histogram, and I can see that I said we'll draw 1,000 values from a normal distribution and generate a histogram, which I left a T out of. That won't fix yours, but it fixed mine. And I'm actually going to change the number of bins to 20 to match the text. So I'm just drawing random numbers here, and I'm going to plot them against the X value, and we'll have 20 bins. So basically, that's what you would draw. And then if I repeat that, because I'm drawing random numbers, it's not going to look the same. And I can change the number of bins that I'm collecting things into. Let's switch it to 100. 100. And you can this time the changes will be more obvious. So that's how you can plot a histogram. You may not know what a histogram is yet. We'll talk about it, but that's how you do it. So there are lots of ways of defining colors in Matplotlib. I'm going to show you the simplest, but I'll tell you that the Matplotlib will interpret standard HTML color names. It understands all of the different ways of specified colors that are used in computers, and so basically. Blue is, but the simple is blue is a little bit a lowercase b, G is green, R is red, C is cyan, M's magenta, Y is yellow, K is black, and W is white. And so that will give you enough colors for most purposes. But I also see that I typed the strings instead of strings. Let's see. But anyway, you can specify colors using HTML strings. I'm not going to show you how to do that, but if you know about it, you can use it. The colors that you just using the lowercase letters are going to be enough for us. But anyway, what I'm going to do now is I'm going to look at an example and with color changes in it, and so this particular one is just illustrated or used to illustrate some colors, but basically what I've done is I've plotted two things on the graphs, and I've used a letter color in one of them. I've used a number color in the other, which gives me shades of gray. And I've just done a number of different plots, and just wanted to illustrate to you. I'm not expecting you to follow what I've done here. I've done something with means and standard deviations, but I just generated a couple of different plots in there for you to look at. Okay, I now want to talk about decorating your plots, because you are going to want to be able to not just have a plot. You're going to want to do things to it. You can color it, but you might want to label things. You might want a title and all of that. So the first thing I'm going to do is I'm going to show you how to put a title on. And the way to put a title on is basically to add this plot title. Oh, and also, I'm this time going to plot up a polynomial, and I've created an x value that ranges from -4 to +4, and has 1,024 points in it. And then for the y values, I'm just going to calculate values of a particular polynomial, which is a quarter x to the fourth multiplied by x multiplied by 1 over the square root of 2. Sorry, it's the terms are a quarter multiplied by x to the fourth, and then I've got done a couple of other things where it's just a polynomial term which I'll plot out. So we'll plot it, and it looks like this. And the main thing here is I put the title a polynomial on it, and it came out in red. What if I wanted a different polynomial? Lawrence, go ahead.
Yes, the polynomial that you've created here, it's in its factored form, obviously.
It is, yes.
Can you write the thing in its expanded form using the?
Yes.
Okay.
Yes.
Okay,
Yeah.
it understands that.
Yeah. I realized when I was writing it, I factored it. I actually have it written in its expanded form a little lower down. I forgot that I factored it.
Okay. Thank you.
But yeah, it's a bit more efficient to do it that way. So actually, in the very next line, I've got it written in its expanded form, and what I've done is I've used in this case. LaTeX to generate the title and to specify what the polynomial is. So if I run the next one, you can see that is actually what the polynomial is.
That's neat. Thank you.
So anyway, but yeah, the first time I did this, I'd written out all the terms and I'd forgotten that I'd switched it to factored form, which I was thinking, have I done this wrong? And then it struck me, oh, I factored it. But anyway, which makes it much harder to read out. And you might notice that the color solution is arbitrary. So I got a red polynomial the first time, and I got a magenta one the second time. The next thing is it might be useful to label what the quantities actually are. Because this particular graph came from a research project, and this actually represents the power curve for an airfoil, and so the coordinates were airspeed and drag, and so in this one I've actually written those things, and we'll run this one. And you can see we've got a title, we've got a label for the x-axis and a label for the y-axis. So we can go ahead and run this one. And I also specified that the curve was blue for this one. So you can see that then what it's the power curve of. When you've got graphs, you might also need to be able to label pieces on the graph. Can you do that? And the answer is yes, you can. So basically what I'm going to do in the next one is I'm going to keep the labels on the axis. I'm going to keep the title, the label axes. But what I've added in is I've added in the maximum or the minimum of the graph and a local maximum on the graph, just to label them. And you might notice I've got numbers on them, but let me run this, and I'll show you about the numbers. So you can see I've got a local maximum labeled. here. I've got a minimum labeled because it is the minimum. This is a local maximum because there are higher points over here. And you might wonder, how did I get these labels in the right place? Well, the answer is trial and error. So I knew that the y coordinate ranged from somewhere below 0 up to plus 20, and the x coordinate ranged from -4 to +4. So, and you might wonder what these are speeds relative to the airfoil. So that's where the minus signs come from. But anyway, so you can see that if you look at minimum, I've got the two numbers before it, and they're 0.2 and 0.2. And essentially, those are the numbers at which the x and y coordinates of that label start. So, for instance, if I take this 0.2 here, and I make it to 2 for where the minimum is, and that's the y coordinate, and I'll run that. You can see that what happened is that the minimum just jumped up, or the word minimum jumped up. And if I want to go back to 0.2, it will be just lower down. Now, if I change the x coordinate to 2, that's going to cause bigger problems, because the minimum is nowhere near an x coordinate of 2. So if I run that, you can see the word minimum starts at an x value of 2, which obviously isn't the minimum. So I'll move that back to 0.2, and then it's back to where I want it. So how did I do that originally? I just guessed starting points, and then I looked at the scale and moved them to where they would make sense. So anyway, so in terms of this, is there any way to do this automatically? Not with these basic plotting routines. However, when we incorporate pandas, the statistical package, and we run the matplotlib through pandas, it will actually do more things automatically. Just not this. This you pretty much are going to have to do by hand. And I guess to make it really nice, we might want to put boxes around those labels. And so I've added commands to draw some shaded boxes around the labels. That's the only change. And let's do that. And you can see it just put those boxes which have shading in them. I prefer not to box them, but if you wanted to do it, that's how to do it. But I just included that for completeness. So that's the basic introduction to Matplotlib. What if you need to know more? Well, there's an official tutorial. And the official tutorial is linked at this point. Can you color the text? Yes, you can. But here's the official tutorial. So I'll go to it, and so here's the PyPlot tutorial. It has an introduction. It shows you, it has different examples to the one that I used. It shows you how to plot dots. It shows you how to plot the categorical values. It talks about controlling the properties of the lines and gives you lots of options. It tells you how to work with multiple figures. It tells you how to work with text. It talks about annotating the text, which I showed you, although it uses a slightly different method. It shows you how to change the axes to logarithmic axes. So pretty much anything basic that you wanted to do with PyPlot can be found in this tutorial. And if you want something more complicated, click on tutorials and you'll see that there's a quick start, there's a custom, and then there's intermediate and advanced guides. There's how to play with the text, how to play with colors, so those are tutorials. There's lots of examples that you can use to steal things from. It will show, and if you click on them, it will show you how they got them. There's a reference manual that tells you everything under the sun about Matplotlib, and there's information about all of the different sorts of plots that you might need to draw. So in the time we have available, I can't possibly show you all of the things that everybody might need to be able to do. But if you need a different sort of plot, then this shows you how to do those, and shows you how to do multidimensional ones, shows you how to draw grids, and all of those things. So that's a useful tool for you. And it is linked from the file. Okay, I encourage you to play with some of the plots tonight. But now I want to start introducing you to pandas. Carl, go ahead.
Oh, I just posted my question in chat, but I was just wondering, like, how would you add like a legend to your plots if you, for example, you have like more than like one colored line?
Well, the same way that I did. You would just put labels on each of the axes. That's the easy way to do it.
Okay, thank you.
So I will tell you that most of the time in the time I have with you, I'm going to show you mostly the easiest way to do things. Not necessarily the way that I would normally do them, because the ways that I produce publication graphics are far more complicated, but the simple methods work, and I've published some of the methods, some graphs using these simple methods. Okay, the next major package that we're going to use is pandas, and pandas is basically the Python package for data analysis, and it is the package that we'll use more than any other. And it actually re-implements a lot of the matplotlib stuff, and will do quite a bit of it automatically. But some things you'll need to do by hand, which is why I started out by showing you how matplotlib works. So, and if technically what pandas does to matplot lib commands is put wrappers around them and run matplotlib under the hood. So one of the things is that there is documentation for pandas, but the people who write the documentation tend to lag at least 6 months behind the people writing the package. So I'll show you how to find that documentation later, but recognize that it's always a little bit out of date. I mentioned when I began the afternoon session that I would to introduce this, I would use Plot with Pandas Python Data Visualization for Beginners by Rika Hovarth, and this is where that adaptation begins. But I'm going to go visit that page and show you what it's like. So basically, this is a tutorial on how to plot with pandas. And this one assumes that you're setting up an environment. So it starts out by telling you how to download Anaconda and all of that. And then it quickly gets you into to loading a data frame and creating plots with it, which will duplicate. It tells you how it works. And it does all sorts of things with it, but anyway, you will see that pretty much we will end up doing the same, except that instead of writing it as raw code and just producing the graphs, we're going to have it in a notebook. But one of the reasons for doing this is that if there are things that you aren't sure about, this web page will provide a detailed explanation of everything that's going on. So anyway, that is the web page. So the first thing that we've got to do is we have to be able to import pandas, and what I'm going to do is I've opened it with import pandas as PD. Again, that's the standard way of importing the data analysis tool, and PD is the standard abbreviation. So I've done that, and then the first thing I'm going to do is to show you how to download a data file from a remote location. What I've done is I've basically created a variable which I've called download URL. Now I could call this anything I wanted to. It is a download URL, where URL means Universal Resource Locator. So why not just call it that? But I mean, if I wanted to call it Fred and write Fred here and write Fred in the next line, it would still work. I prefer to call things that mean call things names that mean something. But what I've done in there is I've given it the web address of a data file which has the ending .csv. CSV is what is called a comma-separated variable file. And it's one way, or a very common way, of shipping around data. Tomorrow, though, I will show you that not all CSV files are created equal. And if you get an error when you download a file yourself, I'll show you something to try that usually fixes the error. There's an old version of CSV files and a new version. And if you happen to find an old one, they have to be treated just a little bit differently. Anyway, so then what I'm going to do is I'm going to use this, and I'm telling pandas to read in a comma separated variable file at this location, And by the way, I could have put everything in that parenthesis, but it's good practice to name it as something and do this. And I'm calling the data frame, which is what the data will be stored in, DF. I'll mostly call my data frames DF and examples. However, you can call them anything you want. And if I was using multiple data frames, I might give a name descriptive of the data pool where the data frame came from. But anyway, and so what this will do for me is it will import pandas, it will download it into a data frame, and then what I'm going to do is I'm going to ask what the type is of this variable that I've called df. Now I know it's going to be a data frame, but it will tell me that. So let's run this piece of code. If I didn't have the word type df in there, it wouldn't have produced anything. But what it tells me is it's a pandas core data frame, and it tells me that it's a two-dimensional size mutable, and it tells me it contains labeled axes, and it tells me all sorts of things that I might want to know about it, but it gives you generic information about data frames. So and type will always do that. Okay. So essentially that thing read CSV, which I use for a comma separated variable file. If it had been a different sort of file, I'd have specified what sort of file it was. It creates a data frame, and that's the main data structure used in pandas. The type tells me about the object that I downloaded, and I knew it was going to be a data frame, so that's why I named it that way. What I'm now going to introduce you to is some terms that are used to learn about what's in a data frame. So, have you met data frames before? If you've seen an Excel file, so Shabella asked if she's the only one, or maybe he, I'm not sure, if they're the only one unable to access the file. I'm not sure which file you're talking about, whether this one. Okay.
Yes, I was talking about the same one. So when I tried to click on it, it's saying, oh, okay, I think it has gone through now. Okay, yeah, it has gone through. Thank you.
Okay, great. Yeah, sometimes it takes some time. So the thing is, probably everybody hit the file at the same time, and I'm not sure what the bandwidth of that website is. The 538 is a website that has lots of commercial data on it. Anyway, so now what I'm going to do is, well, let me back up. Have you seen data frames before? Probably. If you've ever looked or seen CSV files, Excel files are basically CSV files with a slight modification. So what we're looking at here is something that looks like an Excel file, but a really big one. If you are used to Excel files, you're probably used to looking at them. But in data science, we don't look at all the data. We try to analyze it automatically, so we don't have to go and do everything by hand. But what we might want to do is to get an idea of what the data in the data frame looks like, and this command, which is basically the head command, and so I'm saying I want to look at the head of the data frame. So let's run that command and see what happens. And this is a data frame about college majors and employment and things like that. And if I issue the head command, what it does is it shows me the first 5 lines in the data frame, and it tells me that it's showing 5 rows by 21 columns. They're not all on screen, but I can slide over there. And you might see that when I slid over there are a couple of things. These are some AI tools that Google has added in, and I mean, you should explore and see what they do. So let's click the calculator and see what it does. And what it did was it changed it into a data table notebook. I'm not sure that it's any better, but it says it also that there were 21 columns and it limited it to the first 20. So to go back, I'm going to rerun the command. And you can see what it eliminated were the number of people in low-wage jobs, because that's the 21st column. But anyway, the other command clearly is going to do a plot of some kind. It may not be very useful on this data, but we'll go ahead and do it. And so some plots are generated, and actually lots of plots are generated. They don't look to be particularly useful at this point. There are some error messages. But anyway, that's what it generated. Sometimes you'll see some useful things. Most of the time you won't, but it'll do that. The other thing is, you might notice that tool truncated the data frame. And it turns out that sometimes when you load a data frame, Pandas itself will truncate a data frame and not show you all the columns. But if you want to be sure that you see all of them, you take the simple command I had in the first time, which was df head. You can modify that and say, first put in a pandas option to display, to not have a maximum on the number of displayed columns. And so if it exceeded its default, it would go ahead and show them. It won't actually change anything here because 21 is below its maximum, so it looks the same. But if you ever if you ever need to display more columns, that's the way to do it. Okay. You can look at the top of a data frame. You can look at the bottom of the data frame. And when I looked at the top, I just used df head and parentheses. Well, the bottom is then the df tail. And so what I'm going to do is I'm going to run df tail, but notice I've written 12 in there. So I've actually specified that I wanted to show me 12 lines. So if I do that, you can see it shows me more lines, shows me the same number of columns, but this is what the bottom of that data frame looks like. And sometimes that's useful to look at. So anyway, you might think, well, there's what, 100 and so it goes up to 172 or maybe 173. So you might think to yourself, well, I want to see the whole thing. So what if I put 173 in there? What happens? Well, of course, you're free to try that. And if you try it, it only produces the the top 5 and the bottom 5 for you. So if you specify too many, and it's got dots in the middle to show that it hasn't displayed them. So this command will not show you all of the rows in a data frame, even though you might want it to. Okay,
So like had
Go
a
ahead.
question.
Go ahead.
So what's the maximum of rows it's gonna show you? Is it 10?
No, because you see, I did manage to make it show me 12. It's just that if you put in numbers too big, it's going to truncate it to 10. The number it shows. Let's see. So this is 162 to 173. Let's change this to 15 and see if we can get 15. Yeah, so we got 15. But I think if we go to 25, we won't get 25. Yeah, so it took us from 155 to 172. So somewhere around 20 is the maximum. So anyway, I think this is just so if you just put in DF, it'll give you the head and the tail. But a lot of times it's better to list them separately. Okay. So that's some basic operations you can do with data frames. Now what I'm going to do is I'm going to do a plot, and the plot. Well, let's just do it. So the plot is much simpler than it was in Matplotlib. It's just data frame plot. I've said that X is rank, and I've given Y values, and we'll go ahead and do the plot. So you can see that the X label is rank. It didn't give a Y label, but it does tell you that the individual plots are. The orange one's the median income, the blue one is the 25th percentile, and the green one is the 75th percentile. But that shows you how you can plot 3 of the curves on a single plot. So the Sahid said he's a bit of a loss. Where do you get the data set? The data set comes in too far. The data set is loaded by these pieces of code here. So basically, where I said we'll look at plotting from pandas, I went out and pulled down a publicly available data set and loaded it in, and then I'm just using it from here on in. So you have to load the file, and you have to run those pieces of code to get the data frame and be able to do this. So does that help? So you can make observations about what happens, and some majors have large gaps between the 25th and 75th percentile, and the others have small gaps, and you can see them. There's a small gap here. So basically, what this plot tells us is there's a lot of information to be discovered in this data set. Some majors have a wide range of earnings, others have a narrow range. And to discover those differences, we would have to look at different sorts of plots. So you can plot other columns. Here I'm going to plot rank and so you can see I've got college jobs, non-college jobs, and low-wage jobs. We can make that plot. So essentially, there's lots of options within plot, and I just tell you what they are. Areas for area plots, bars for bar charts, bar H for horizontal, boxes for box plots, hexbin for hexbin plots, hist for histogram, KDE for kernel densities, which you need to know statistics. Density is an alias for KDE, and so on. This will make more sense when you come back to this one after we've looked at some of the statistics. If you don't provide a parameter, it creates a line plot, and basically what I'm going to do is I'm going to show you how to make a plot using the first two columns of the data frame. So I'm importing matplotlib.pyplot as plot, and I'm going to say plot the column rank against the column 75th percentile, and we'll get that. So that's how we would have plotted that graph using the methods I began by showing you, just using matplotlib directly. But it turns out that matplotlib will do this directly, and it's much easier to do it directly. And here, all we had to say was data frame plot, x equals rank, and in this case, I've chosen the 25th. And so if we plot that, we get exactly the same graph, except that the column or the line that we're plotting is specified, and we're told that the horizontal axis is equal to rank. So it actually does more for us in about the same amount of space. So what you can do, or one of the things that you're going to want to do when you have data to look at, is you're going to want to take this worksheet and you're going to want to do the same sorts of things with your data that I'm choosing to do with this data, because basically that's what it's going to be all about. So you can use plots to explore your data sets. So what I'm going to do is I'm going to look at a general overflow, and the data frame is not the only thing with the plot method. A series object provides the same functionality, and you can get columns as series objects. So what I'm going to do here is I'm going to create a series object, and I'm going to basically extract a single column from this data frame. And so what I'm going to say is that I'm going to call a new variable median column, and what I'm going to say is I want to set the median column in the data frame into that median column. And then what I'm going to do is I'm going to create I'm going to ask it what sort of object is that series column. So if I'll run it, it tells me it's a pandas core series object, and it tells me what series objects are, and they're basically one-dimensional arrays. And once you've got a series object, you can make a plot of it. And what I'm going to do is I'm going to plot a histogram of the median column, and basically I'm going to. It turns out that it automatically chooses bins, and let's draw it and see what we come up with. So basically, it puts the distribution into into histograms, and the bins range from each have a width of $10,000, and you can notice that there's a histogram here, and then there's a histogram here, and then there's an outlier here. And basically, it looks like one data point has its own category. And what that means is the people who major in that field get an excellent salary compared to the average, but also compared to the runner-up. And although it's not its main purpose, histograms are really good at helping you detect outliers. So what we might be interested in is which majors does this outlier represent? How big is the edge? So basically, what I'm going to do is I'm going to create a new data frame from the original one, and I'm going to call it top 5. And what I'm going to do is I'm going to sort the values by the median, and I'm going then to look at the head of that folder. So I haven't plotted it yet. So now that we've got top 5, I'm going to plot it. And so these are the median salaries, and these are the median incomes for the top 5 salaries for college graduates. So notice, first of all, you can see what the outlier is. It is petroleum engineering. And then the next highest salaries are mining and medical engineering. Next comes metallurgical engineering. Then we have architecture and marine engineering, and then we have chemical engineering. So for all of the majors looked at, those were the highest salaries. And by the way, you might have noticed that I rotated the labels here. So I plotted the major for the top 5. I took the median salaries. I wanted a bar graph. I chose a font size of 10 units, but this rotation of 80 rotates those labels. And the reason, well, I'll take it out and show you why I did that. So I'll just take that piece out, and I'll rerun it. So I mean, it's readable still, but was I thought it was a bit more readable when they were rotated. So I can go back and I can put that back in. And that simply rotates my labels a bit, which makes them just a little easier to read. The other thing we could do is we could look at the bottom 5 majors, and let's do that. So you can see that the salary medians here are quite low, and the bottom five majors in this list were library science, counseling psychology, clinical psychology, educational psychology, and zoology. So those were the lower paying majors in the list. But I created a separate data frame by sorting them and by median and basically just took the tail of this to get the bottom five, and where I'd used head to get the top five. And then I can just plot it, and I plotted major against median salary. I wanted a bar chart, and again, the font size of 10. And so there you have it. And the basic takeaway message is that at the time the study was done, petroleum engineers earned a median salary more than $20,000 higher than the next major. Now, I understand that these are salaries for people with bachelor's degrees. The earnings in second through fourth place were fairly close. And so basically, one of the things that we could do is we could just analyze part of this data, so I'm going to investigate all majors whose median salary is above 60,000. So the basic thing that I've done is I have created a data frame for the top medians, and it's by taking the salaries above 60,000. And again, I'm going to do the usual plot.
I apologize for the interruption, but we have 15 minutes left, and then we will have a 15-minute break.
Okay.
So you're almost there. Thank you.
So we're actually in good shape because we are close to the end. So anyway, that shows you some of those majors. So investigating outliers is important. Something else that is important is looking for correlations between columns. And so what I'm going to do here is I'm going to do a plot of my data frame, and I'm going to look for correlations between median salary and unemployment rate. And so if I do that, it produces a scatter plot for me, and that should show you that there's no significant correlation between earnings and unemployment rate. And a scatter plot is an excellent tool for doing that. It's not definitive of there being a connection, but looking at a quick scatter plot can be a good way. You can do this between all pairs of numerical values in the data frame. You can look for to see if there's any relationship between the variables, because if there is, the scatter plot might look like a line or a curve, not just an amorphous blob like we have here. So the final thing that we have to look at is analyzing categorical data. So basically, in the current example, there are 173 majors, but they're actually divided into 16 categories, so one of the things that we can do is you can tell it to group by a major category, and STEM is a major category, for instance. I can tell it to group by the major category, and then I can figure out how popular each of the categories are. So if we do that, you can see that in the data, you can see how many people are in each of the categories. And in this case, agriculture and interdisciplinary weren't very popular, but there were hundreds of thousands in most of the other categories. And over 1 million in business. So one of the things you can do if you have categories is you can use it to form groups like that. And you can also zoom in on categories. So I'm here choosing to zoom in on engineering. And if we zoom in on engineering, again, we can get a plot. So that's basically how to do categorical information. So what I've done today is I've shown you a lot of things that you can do with data frames and how to get out plots and how to do some all sorts of different analyses. And I've introduced you to commands. Tomorrow, what I'm going to do is I'm going to actually pick a different data frame, and I'm going to show you how to do more things about it, and show you the sorts of things that you might want to do in a data analysis. So pretty much everything I've introduced today, I'm going to come back to tomorrow and use. And so it would be a good idea to take some time running through these objects tonight, and just getting an idea. You'll find that there is more. I wrote more in the explanations than I actually covered here in class today. But anyway, it would be a good idea to go through these. Now, again, tomorrow you will have, I'll provide some data sets to you. And I have also already provided the sets of slides that I'm going to use tomorrow. And I think I guess I haven't uploaded the data sets. I'll upload those data sets that you'll need to use into the student binder tonight if you want to get, so that you have them available. Actually, let me see, do I still have yeah, I haven't uploaded the data sets yet. I'll do that this afternoon. So Mercy, go ahead.
I'm a little bit confused. How do I upload data to Collab from my drive?
Yes.
Yeah, how do I upload data?
I haven't shown you that yet. All I've shown you how to do is how to download it from the internet. Tomorrow, one of the first things I'm going to do is to show you how to upload data from your drive. But I haven't shown you how to do it yet. The reason for that is I wanted to focus on using it first, and also it turns out that there are 3 different ways to upload data to your Google Drive. And one of the things that I want to do is to see which one is currently working the best, because it turns out that over time, Google plays with these, and at various points, one of the 3 methods works better than the rest. So I'm going to figure out which method is working the best currently, and we'll focus on using that one. Last time I did a workshop, one of the methods wasn't actually working at all. Because Google was doing some maintenance on it, and why they provide 3 different methods your guess is as good as mine, but they do, and they keep changing them a little so that they work differently and look differently. And so pretty much to decide which one we're going to use, I have to test it the day of the workshop. But I will actually do some testing tonight and make sure that we use one that is actually working. I've done some testing earlier this week, and I've written it around. I've described 3 methods, but I've written most of the lessons around using a single method because it appears to be the one that's currently working the best. As I said, I will upload a couple of data sets for you this evening so you can download them and get them onto your Google Drive. There'll be .csv files. So I think one of them is housing data, and the other one is some salary data. But anyway, I'll do that, and I look forward to seeing you tomorrow. And after the morning session tomorrow, you will be able to start loading your own data sets in and doing things. But there's more things I need to show you before I want you to do that. So Algelia, go ahead.
All right, so just based on everything we've learned today, as far as Google Colabs, I'm understanding like this is like for lack of better words, like the practice space to learning Python. So those sites that you shared with us earlier, we should like all that should transfer over into those like actual Python practice sites too, right? Like if we go to Python practices or areas.
So those are things that you would learn after you have more experience with Python. I wanted to get some practice without having to worry about the overhead of running a Python distribution yourself, because that takes some effort, and when you know what the reward is going to be, you'll spend the time. But if I started you out by downloading Python packages, downloading all the pieces you need to make them work, a lot of people would have bailed out in the first session. And also professionally, professionals use Google Colab all the time. So many people don't even use one of the distributions themselves anymore. They just use Colab. It's very widely used.
Okay, thank you.
Okay. Well, have a good evening, everybody. I guess I'll stop my screen sharing here at this point, and I'll remember to stop the recording.